Okay, so in this unit, we're going to talk about factoring expressions. We're going to start by finding the greatest common factor of an expression. So this is kind of the opposite of multiplying binomials or distributing. So let's start with our first example. So in this case, I'm going to review how to distribute expressions with exponents. So let's start with the first one. So we're multiplying negative 4x to the xy to the third times 8x squared y squared. So remember, if there is no exponent, the exponent is going to be 1. So I'm multiplying negative 4 times 8, which is negative 32. X to the first times x to the second. Remember, I'm adding my exponents, so I get x to the third power. And then y to the third, y to the second would be y to the fifth power after I add my exponents. All right, so now I want to do the same thing. I'm going to distribute that negative 4xy to the third to negative 7x. Well, a negative times a negative is going to be a positive 28. And then again, if there's no exponent, it's going to be x to the first. So if I add those exponents, I get x to the second power. And then that y to the third just stays there just the same. So my final expression would be right here. Looking at my next example, now I'm multiplying binomials. So this should be a review of what you should have learned last unit. So it's kind of like double distributing. I multiply the first terms. So 3a times 3a is going to be 9a to the second power. 3a times 5 is going to be 15a. Negative 5 times 3a is negative 15a. And then my last one is going to be negative 25. So I'm double distributing. I distribute the first and then I distribute the second term. So remember, back to last unit, the only like terms are going to be those middle ones. So if I combine those like terms actually here, what is positive 15 minus 15? Well, that's going to actually cancel each other out, and we're going to be left with just 9a to the second power minus 25, and that would be my final expression. All right, so hopefully that was a good review of both multiplying binomials and the distributive power. All right, moving on to greatest common factor. So the greatest common factor is the largest factor that all terms have in common. So for example, going back to the basics, if I have 15 and 25, for example, well, my factors of 15 are 1, 3, 5, and 15. My factors of 25 are 1, 5, and 25. So my greatest common factor would be the greatest factor, largest factor that they have in common. And in this case, that would be that 5 for both. So that's kind of going back to what you should have learned hopefully in middle school of greatest common factor. Now we're just going to get a little bit more advanced with this and talk about greatest common factor, including variables. All right, so let's look at number 1, for example. So when I want to find the greatest common factor of this expression, I'm going to look at the numbers and the variables kind of separately. So let's look at our numbers first. So I want the greatest common factor of 5, 25, and 45. So I'll show you kind of the long explanation of this first, and then hopefully we'll get a little quicker with it as we go. So our factors of 5 are just going to be 1 and 5. Our factors of 25 are going to be 1, 5, and 25. And our factors of 45 are 1 times 45, right? What else do we got? Do we have 3 times 15? What else gives us 45? We have 5 times 9, and I believe that is it. So our greatest common factor between all 3 of these is going to be 5. Okay, So that's the numbers. So my greatest common factor for the numbers will be 5. Let's look at our variables now kind of separately. So I have x to the third. Remember, x to the third is the same thing as x times x times x. X to the second is the same thing as x times x. And our x is just going to be x for the last expression. So what do all three of them have in common? Well, all three of them have one x in common, so my greatest common factor of all three of those would just be x. So if I was to write the greatest common factor for this polynomial, it would be 5x. And that would be my greatest common factor. So the 5 is coming from the numbers, x is coming from the variables, and I'm good to go there. Kind of a shortcut I like to think about for the variables. If you're looking at each variable separately, I have x to the third, I have x to the second, I have x. If you look at the one with the least exponent, that is the one that's going to be part of your greatest common factor. So let's look at another example to kind of go over that again. So for number 2, starting with my numbers, I have 3, I have 9, and I have 12. Let's ignore the negatives for now. So my factors of 3 are just going to be 1 and 3. My factors of 9 are 1, 3, and 9. And my factors of 12 are 1, 2, 3, 4, 6, and 12. So my greatest common factor of all three of those is again going to be 3 for this one. So I have my numbers done. Now let's look at our variables. And I'll show you the shortcut again. So if we have x to the fourth, that is x times x times x times x. X to the second is just x times x, and then x would just be x. So my common one of all three of those is just, again, 1x. And remember, I said for the shortcut, it's going to be the least exponent of all three. So in this case, my common factor, my greatest common factor, would be 3, because that's coming from my numbers, x, because that's coming from my variables, and that is all. So remember, that shortcut for the variables, if I look at all three of them, I have x to the fourth, x to the second, x. My least exponent is just the one with the x, because that's like x to the first. So that is the one that's going to go right here. All right. Let's look at number 3. So let's start with our numbers again. So I have 12 and I have 24. So again, I have 12 and I have 24. So let's list our factors of 12. We already did that in the last problem, so we can just kind of borrow those. 1, 2, 3, 4, 6, 12, and we're good to go. My factors of 24 are going to be similar. I have 1, 2, 3, 4, 6, 12, and 24 for this one. All right, so what would be my greatest common factor of both of them? Well, that's going to be that 12, because that's the greatest one they have in common. So I'm good to go with my my numbers. Now, for this case, I actually have two different variables. I have x and I have y. So let's treat them each separately. So let's look at our x's first. In the first example, I just have x, so that's just going to be x. The second example, I have x to the second, so that'll be x times x. Well, what's in common? That's just going to be that x here. Okay. Lastly, looking at my variables, I have y to the fourth for my first one, and I have y to the third for my second one. Let's think back to our shortcut. Which one do we think it's going to be? Probably y to the third, because that's the least exponent, but let's actually try it out. Y to the fourth is y times y times y times y. Y to the third is y times y times y. Well, how many are in common? There are 3 in common, so I would say that would be y to the third there. So my final greatest common factor would be 12x y to the third. Okay, so let's look at our last example here. So I'm going to be doing exactly the same thing. Let's start with our numbers. So we have 9, 27, and 12, ignoring the negatives right now. So our factors of 9 are 1 and 9, because 1 times 9 is 9, and then 3, because 3 times 3 is 9. Our factors of 27 are 1 and 27, 3 and 9, because 3 times 9, and I think that is it for 27. Then lastly, my factors of 12 would be, we've already listed them out, 1, 2, 3, 4, 6, and 12. So remember, I want my greatest common factor of all these. So looking through all of these, my greatest common one would be 3. Right? It has to be common in all 3 examples. All right, let's move on to our variables. So looking at each expression, you should notice that not every expression has each variable, right? So our first expression has a to the 4th, our second expression just has a, and our third expression has no a's, right? So if our third expression has no a's, then that's kind of what we have to go with, because there's no a's in common for all 3 of them. They have to be in common with all 3. So that means for this example that a will not be part of the greatest common factor. All right, let's look at the b's now. Are there b's in all 3 expressions? Yes, so let's actually look at each one. Our first expression has b to the 5th, our second expression has b to the 2nd, and our third expression has b to the 3rd. So thinking about our shortcut, it should be the least exponent of all 3. So most likely it's going to be b to the 2nd. Let's write it all out just in case. So b to the 5th is going to be b times b times b times b times b. B to the 2nd is just b times b. And then b to the 3rd is b times b times b. So how many are in common? That's going to be 2 of them in common. Looking at our last variable here, the only one that has a c in it is the second term. So again, not all of them have a c in common, so we're just going to kind of ignore that one, just like we did with the a's. So when we're writing our greatest common factor, we only consider what all 3 of them have in common. So all 3 of them have that 3 in common, so our final answer would be 3. And all 3 of them have 2 b's in common, so b to the 2nd power. I can't include an a here, I can't include a c, because they don't all have an a and a c in their terms. So our last answer would be 3, b to the 2nd, for that greatest common factor. All right, so I want you to try some of the your turns on your own, and then refer back to this video if you have any questions during the choice activity or the objective quiz. All right, until next time.